Tonight, we're going to explore a moon so cold, so silent, that for centuries we assumed nothing could survive there. 600 million kilometers from where you're lying right now, a small ball of ice drifts through the crushing dark, orbiting a giant so massive it could swallow 1,000 Earths whole. Its surface is smooth, almost unnaturally smooth, cracked with lines that stretch for thousands of kilometers, like scars healed over and over again. And for a long time, that's all we thought Europa was. A dead little moon, a frozen nothing. But buried beneath that ice, under a shell some scientists believe is 15 to 25 kilometers thick, is a truth that rarely gets mentioned in the quiet comfort of a bedtime story. An ocean, not a puddle, not a pocket of melted ice, an ocean that may hold more liquid water than every sea on Earth combined. Dark, pressurized, utterly without sunlight, and it has likely been sitting there, sealed away for billions of years. Here's the thing most people don't realize: that ocean shouldn't exist. Out there, this far from the sun, everything should be frozen solid. Brutally, permanently frozen. And yet something is happening beneath that ice. Something is generating heat. Something is keeping that vast hidden sea alive in the dark. And once you understand what that something is, you'll understand why so many scientists lie awake at night, wondering what else might be alive down there with it. By the end of tonight, you're going to understand exactly why this small icy moon has quietly become one of the most watched, most debated, most unsettling places in our entire solar system. Not because of what we found, but because of what we haven't ruled out. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds, like yours. Now let's begin. So let's start where all of this begins, not with the ocean, not yet. Let's start with the moon itself, floating there in the black. Because before you can understand what's hidden inside Europa, you need to understand what it looks like from the outside. And I promise you, it's stranger than you'd expect. Picture Jupiter first, not Europa. Jupiter, because everything about this story orbits around that planet, literally and otherwise. A gas giant so enormous that if you hollowed it out, you could fit more than 1,000 Earths inside it. It dominates the sky out there, a storm-streaked giant, orange and cream and rust-coloured, silent and indifferent, spinning through the dark. And around it, caught in its gravity like a moth that never quite escapes the light, drifts a small pale moon named Europa. Here's the thing most people don't realise. Europa is small, smaller than our own moon. If you set it beside Earth's moon, you'd have to look twice to tell it apart. Just slightly smaller, slightly dimmer. And yet this modest little sphere has captured more scientific obsession, more quiet fascination, more late-night speculation than almost any other object in the solar system. Why would something so small matter so much? That's the question this whole story is trying to answer. From a distance, Europa looks almost gentle, white, smooth, faintly marked with thin reddish-brown lines that wrap around its surface like veins beneath pale skin. No mountains rise from it, no craters gape open in violence, just ice stretching in every direction, catching the distant sunlight and throwing it back in a soft, cold glow. It looks peaceful. It looks, if you didn't know better, like nothing could possibly be wrong down there. But you do know better. You already sense it, don't you? That stillness on the surface isn't the whole story. It never is out here. Let's talk about where Europa actually sits, because the numbers alone tell you something is strange about this place. It orbits Jupiter at a distance of roughly 670,000 kilometers, close enough that Jupiter fills the sky above it, a bruised, swirling giant, hanging enormous and unmoving on the horizon. Europa completes one full orbit every 3.5 days. 3.5 days compared to the 27 days it takes our own moon to circle Earth. Out there, everything moves faster. Everything feels tighter, more urgent, more entangled with the planet it orbits. And that entanglement matters. It matters more than almost anything else in this story, though we'll get to why very soon. For now, just hold on to this feeling. Europa isn't drifting freely through space, doing its own quiet thing. It's caught, pulled, squeezed gently but constantly by the gravity of the giant beside it. Nothing about this moon exists in isolation. Now picture standing on that icy surface, if such a thing were possible. The sky above you wouldn't be black, not entirely. It would be dominated by Jupiter itself, a presence so large it would blot out a third of the horizon, its bands of clouds slowly churning, its great red spot a storm larger than our entire planet, silently rotating in the distance. And the sun, our sun, the one that warms you right now as you drift towards sleep, would be nothing more than a bright, distant point. 250,000 times dimmer than it appears from Earth. Cold, small, almost irrelevant. That's the first thing you need to understand about Europa. It exists in a kind of permanent twilight, far from the warmth we take for granted, wrapped instead in the gravitational grip of something far larger than itself. Complete silence out there. No wind to carry sound, because there is no real atmosphere to speak of. No water lapping at a shore, because whatever water exists is frozen far above where a shoreline might have been. Just stillness, just ice, just that long, patient watch beneath an alien sky. And yet, even in that stillness, there are hints, small clues scattered across the surface, if you know how to read them. Long, reddish streaks cross the ice in every direction, some of them thousands of kilometers long, curving and intersecting like something scratched them there deliberately. Scientists call them lineae, cracks essentially, fractures in the ice, stained by minerals or salts pushed up from somewhere underneath, somewhere below the surface. And that word underneath is where this whole story is really heading. Because here's what should unsettle you, gently, the way all good bedtime mysteries do. A truly dead moon, a moon that is simply frozen and inert from its outer shell to its rocky core, shouldn't have fractures like this. It shouldn't have surface features that look almost fresh, almost recent, as though something keeps rewriting the ice from below. A dead world stays still. It doesn't rearrange itself, but Europa's surface, smooth as it looks, is anything but finished. You might be tempted to think of Europa as small and simple, a minor moon, one of dozens circling Jupiter, barely worth a second glance. But smallness out here in this story is deceiving. Smallness hides things, and what Europa hides sealed beneath that quiet, ice-white shell is something almost too vast to imagine. Something we'll begin uncovering very soon. For now, just sit with the image. A pale little moon, drifting close beside a giant, marked with strange red scars, glowing faintly under a dim and distant sun, still, silent, patient. And underneath all of that stillness, a secret, waiting exactly where it's always been. Waiting, in fact, for us to finally learn how to look. Learning how to look. That's exactly where this next part of the story begins, because before we understood anything about oceans or ice shells or hidden warmth, someone first had to notice Europa was even there at all. And that moment happened a very long time ago, on a cold night in a small Italian city, with nothing more than a handmade telescope and a patient, curious eye. The year was 1610. A scientist named Galileo Galilei pointed his telescope, a crude instrument by today's standards, toward Jupiter and noticed something unexpected. Tiny points of light near the planet, moving night after night, shifting position in ways that made no sense if they were simply background stars. He watched them for weeks, he sketched their positions, and slowly he realized what he was actually seeing. Moons, 4 of them, orbiting Jupiter the way our own moon orbits Earth. Europa was one of those 4. Along with Io, Ganymede, and Callisto, it became part of what we now call the Galilean moons, named in honor of the man who first noticed them glinting faintly beside that enormous planet. For centuries afterward, Europa remained little more than a dot, a pinprick of light, far too distant and far too small for any telescope of that era to reveal real detail. People knew it existed, nobody knew what it actually looked like, and that's how things stayed for over 350 years. Europa drifted in near total mystery, a name on star charts, a faint companion to Jupiter, visible only as an undefined smudge, even through increasingly powerful telescopes. It's strange to think about, isn't it? An entire moon, sitting there in the dark, keeping its secret simply because no human eye had ever gotten close enough to see it clearly. That changed in the 1970s when two small spacecraft, Pioneer 10 and Pioneer 11, became the first human-made objects to travel through the Jupiter system. They weren't designed to study Europa specifically. They were explorers, really, testing whether spacecraft could even survive a journey that far from the Sun, that deep into the punishing radiation surrounding Jupiter. But as they passed by, their cameras captured something new, blurry, distant images of Europa's surface. And even through that grainy, imperfect view, something felt off. The surface looked smooth, unusually smooth, not cratered and battered like our own moon, or scarred with the violent history you'd expect from billions of years of asteroid impacts. Just smooth, pale, and strange. Scientists studying those early images weren't quite sure what to make of it. Perhaps it was simply the low resolution of the cameras. Perhaps a clearer picture would reveal all the expected scars and craters hidden just beyond what those first instruments could resolve. The answer came a few years later, and it only deepened the mystery. In 1979, two more spacecraft, Voyager 1 and Voyager 2, swept through the Jupiter system on their way toward the outer solar system. This time, the cameras were better, the images sharper, and when scientists gathered around monitors to look at Europa up close, for the very first time in human history, what they saw left many of them quietly stunned. The moon wasn't just smooth, it was almost impossibly smooth, nearly free of large craters, nearly free of mountains. Instead, the surface was covered in long, dark, reddish streaks, crisscrossing the ice like scratches on a frozen window pane, some of them stretching for thousands of kilometers. It looked less like a solid ancient rock, and more like something that had been resurfaced, smoothed over, rewritten somehow, again and again, erasing whatever history had come before. Here's the thing most people don't realize about craters in space. They matter more than they seem to. Every moon, every planet without a thick atmosphere accumulates impact craters constantly, struck over and over by asteroids and debris across billions of years. Look at our own moon, and you'll see that history written plainly across its face. Countless craters overlapping, a record of violence stretching back to the earliest days of the solar system. Europa should have looked the same way, and it didn't. A surface with almost no large craters means one simple, unsettling thing. It's young. Not young compared to a human lifetime, but young geologically. Scientists estimate Europa's icy surface is somewhere between 20 million and 90 million years old, a blink of an eye compared to the 4.5 billion years the moon itself has existed. Something has been erasing the old surface and replacing it with new ice, again and again, throughout its entire history. Something active, something still happening, possibly even now. And then there were those strange reddish lines, the ones scientists came to call lineae, long cracks, stained with some kind of mineral or salt, running across the ice in patterns too organized, too deliberate looking to be pure coincidence. Some crossed each other at odd angles, some seemed to shift and reopen in different places over time. It was as if the ice itself was alive, in some slow geological sense, cracking and healing and cracking again, driven by forces the Voyager scientists couldn't yet explain. Imagine being one of those researchers, gathered around a projector in a dim room, watching these images appear for the very first time. No one had ever seen this world up close before, and instead of a dead, cratered rock, they were looking at something that looked disturbingly alive, fractured, restless, young. A small uncertain silence settled over the room, the kind that happens when a discovery raises far more questions than it answers. Because if the surface was being resurfaced, something had to be doing the resurfacing. Ice doesn't rearrange itself. Cracks don't heal themselves. Not without some source of heat, some source of movement, some force acting from below. And whatever that force was, it clearly wasn't finished. Europa wasn't a fossil frozen in place since the birth of the solar system. It was something stranger, something that, in some slow, patient way, was still changing. That question of what could possibly be reshaping an entire moon from beneath its surface would haunt scientists for years. It would take more missions, more data, and one particular discovery from a spacecraft called Galileo to finally begin uncovering the answer. But even in these early images, grainy and imperfect as they were, the truth was already hiding in plain sight. Europa wasn't simply an ice-covered rock drifting silently through the dark. It was something with a pulse, something with a history still being written. And it would take a little more patience and a little more looking before humanity understood exactly what was writing it. Something was writing it. That's where we left things, and that's exactly where we need to keep going. Because before we can talk about what's doing the writing, we need to understand the page itself, the ice, how thick it really is, what it's actually made of, and why its sheer scale is almost impossible to picture, even once you know the numbers. Let's start simple. When you imagine ice, you probably picture something thin, a frozen lake in winter, maybe a few inches deep, something you could crack with a heavy enough boot or drill through with an ordinary tool in an afternoon. Set that image aside completely, because it has nothing to do with what covers Europa. The ice shell wrapped around this moon isn't measured in inches or even in feet. It's measured in miles, many of them. Most scientists estimate Europa's icy crust is somewhere between 10 and 15 miles thick, though some calculations push that number even higher. 15 miles of solid ice, layered above whatever lies beneath. To put that in perspective, that's roughly the same as stacking more than 200 Empire State Buildings on top of each other, floor by floor, and still not quite reaching the bottom. It's a wall of frozen water so deep that sunlight, weak as it already is out there, never comes close to penetrating it. And this is where the analogy really needs to sink in, because numbers alone don't always land the way they should. Imagine drilling straight down through that ice using the most powerful equipment humanity has ever built. You would drill for miles, not feet, miles, through solid, ancient, bone-hard ice, in temperatures cold enough to make steel brittle, in darkness so complete it would swallow any light you brought with you. And even after all of that, you still wouldn't necessarily know exactly what waited at the bottom, because nobody has ever actually done it. Here's the thing, most people don't realise about ice this cold. It doesn't behave the way ice behaves in your freezer. Near the surface, Europa's ice is rock hard, brittle, more like stone than anything you'd recognise from a winter morning. Surface temperatures hover around -260 degrees Fahrenheit at the equator and grow even colder near the poles. At those temperatures, ice doesn't crack gently. It shatters. It fractures under stress the way glass does, sudden and violent, sending long splits racing across the surface in an instant. And that brings us back to those strange reddish lines we talked about before, the lineae. Now that you understand the scale of the ice they're cutting through, look at them again in your mind. These aren't small surface scratches. They're fractures running through miles of solid ice, some of them stretching across thousands of kilometers of the moon's surface, visible even from a spacecraft passing by at a distance. Cracks that deep, that long, don't happen randomly. Something is putting enormous stress on this ice shell, over and over again, bending it until it breaks. But cracks were only the beginning of the strangeness. As spacecraft images grew sharper over the following decades, scientists began noticing something even more unsettling scattered across parts of Europa's surface. Regions where the ice didn't just crack in straight, orderly lines, but instead looked completely broken apart, jumbled, chaotic, in the most literal sense of the word. Scientists eventually gave these regions a fitting name. They called them chaos terrain. Picture a frozen lake if you can, one that's been broken apart into countless individual ice blocks, each one shifted slightly out of place, tilted at odd angles, refrozen together in a jumbled, disordered pattern. Now imagine that same scene, stretched across hundreds of kilometers, cutting through ice miles thick. That's chaos terrain. Enormous stretches of Europa's surface, where the solid ice appears to have fractured into countless pieces, drifted apart slightly, and then locked back together in a frozen, tangled mess. What could possibly cause something like that? A surface simply doesn't break itself apart into floating chunks and refreeze into a jigsaw puzzle without something happening underneath it. Something warm enough, soft enough, mobile enough to let solid blocks of ice actually shift position before locking back into place. Chaos terrain isn't just evidence of cracking, it's evidence of movement, real physical movement, deep beneath a surface that, from a distance, still looks calm and still. Some scientists studying these regions came to a striking conclusion. The pattern of broken, refrozen ice blocks looked remarkably similar to something you might find on Earth. Icebergs drifting in a frozen sea, breaking apart and refreezing along the edges where they touch. If chaos terrain really does form the same way, that would mean something beneath Europa's ice isn't solid at all. It would mean that somewhere below those 15 miles of frozen crust, the ice gives way to something else. Something soft enough to let entire blocks of solid ice float and drift like rafts on a hidden, unseen sea. Sit with that idea for a moment, because it's a strange one. An entire moon wrapped in a shell of ice thick enough to bury skyscrapers by the hundreds. And yet, in certain places, that shell doesn't behave like something solid all the way through. It behaves like something floating, something resting on top of a surface that isn't rigid rock, but something closer to liquid, or at least something soft enough to move. And once scientists started taking that possibility seriously, an entirely new question opened up. If the ice really was floating on something underneath, then Europa wasn't simply an ice ball. It was something layered, something with a hidden structure, a hidden interior, completely different from the frozen, silent surface visible through a telescope or a spacecraft camera. The smoothness, the cracks, the chaos terrain. All of it was starting to look like evidence pointing toward the same conclusion, one that would take a dedicated spacecraft mission and a very particular kind of measurement to finally confirm, because cracked ice and jumbled terrain can only tell you so much from the outside. To know for certain what was happening beneath those 15 miles of frozen crust, scientists needed a completely different kind of evidence, something that could reach past the ice itself and sense what was hiding underneath without ever having to drill a single inch. And in the 1990s, a spacecraft finally arrived that could do exactly that. A spacecraft that could sense what hid beneath the ice without ever drilling a single inch. That's where we're headed now, because in 1995, exactly that kind of spacecraft finally reached Jupiter, and what it found would change everything we thought we understood about this small, quiet moon. The spacecraft was called Galileo, named after the very man who first noticed Europa glinting beside Jupiter almost 4 centuries earlier. It arrived carrying a full suite of scientific instruments, designed to study Jupiter and its moons in far greater detail than any mission before it. But one particular instrument would end up matter more than almost anyone expected going in. A magnetometer, a device built to measure magnetic fields. And magnetic fields, it turns out, can reveal secrets that cameras never could. Here's the thing most people don't realize about magnetic fields. They don't just come from a planet's core. They can also be induced, created almost like an echo, when a moon passes through the magnetic field of a larger body nearby. Jupiter has an enormous magnetic field, one of the strongest in the entire solar system, sweeping through space and brushing against every moon that orbits within it. As Europa moved through that field, something strange happened. The moon itself seemed to respond. It generated its own small magnetic signature, one that shifted and changed as Europa's position around Jupiter changed. Scientists studying this data recognized the pattern almost immediately because it matched something very specific. A response like this only happens when there's a layer of electrically conductive material somewhere inside the object being measured. Solid ice on its own doesn't conduct electricity well. Solid rock mostly doesn't either, but salty liquid water does remarkably well, and the way Europa's magnetic signature shifted matched almost perfectly with the presence of a large conductive liquid layer hidden somewhere beneath the frozen surface. Imagine being in that room the moment this data first came back. Years of speculation, years of studying cracked ice and chaos terrain, of wondering what force could possibly be reshaping the moon's surface from below. And now, finally, actual evidence, not a guess, not an inference drawn from surface cracks alone. A direct signal, detected across hundreds of thousands of kilometers of empty space, pointing toward one specific, almost unbelievable conclusion. Europa wasn't just an ice-covered rock. Beneath that frozen shell, there was liquid. And not just a small pocket of it. The data suggested something enormous. A global layer of liquid water wrapping entirely around Europa's rocky interior, sealed beneath those miles of solid ice like a secret tucked inside a locked room. Scientists had a name ready for it almost immediately, because really, there was only one word that fit: an ocean. A real, honest, planet-scale ocean, hidden beneath the ice of a small moon that most people had never even heard of before that point. And once that word entered the conversation, everything about Europa changed. This was no longer simply an unusual moon with strange surface cracks and mysteriously young ice. This was, suddenly, one of the most significant discoveries in the history of planetary science. An ocean, sitting quietly in our own solar system, hidden this entire time beneath a shell of ice, waiting patiently for someone to finally notice it was there. Think about how strange that realization must have felt, even for the scientists who had spent their careers preparing for exactly this kind of discovery. For centuries, humanity searched the night sky, wondering where else water might exist, where else oceans, seas, anything resembling the environment that gave rise to life on Earth might be hiding among the stars and planets around us, and the entire time tucked quietly beside Jupiter, orbiting in near silence every 3.5 days, there had been an ocean, not on some distant world circling another star, right here, close enough that a spacecraft could reach it within a few years' journey. Of course, confirming an ocean existed only opened up an entirely new set of questions, each one stranger than the last. How deep was it? What was actually inside it? Was it connected to the surface in any way, or completely sealed off, isolated from the rest of the solar system for as long as Europa had existed? And perhaps most pressing of all, the question that would come to define decades of research afterward. Could something be alive down there? But before diving into any of that, it's worth pausing here, just for a moment, to really sit with the sheer strangeness of what had just been discovered. An ocean, existing not on a warm, sunlit world like our own, but on a small frozen moon, drifting through some of the coldest, most hostile regions of our solar system. An ocean that had likely existed for billions of years, completely hidden from view, sealed beneath ice so thick that no light, no warmth, no trace of the outside universe had ever reached it. And this is where the story takes its first genuinely unsettling turn, gently, the way these things always do. Because an ocean that ancient, that sealed off, that isolated from everything else, raises a question that's almost impossible to ignore once you let yourself think about it. What has been happening down there this entire time? What conditions exist in that endless dark under all that crushing pressure and cold? And whether anything, in all those billions of years, might have found a way to survive inside it. Those questions wouldn't be answered quickly. It would take additional missions, additional data, and years of careful analysis before scientists could even begin describing what that hidden ocean actually looked like, how large it truly was, and what forces kept it from freezing solid despite the extreme cold surrounding it on every side. But the discovery itself, that moment in the 1990s when magnetic field data quietly confirmed an ocean beneath Europa's ice, marked a turning point. From that point forward, Europa was no longer just a curious little moon. It had become one of the most important places in our entire search to understand where else in this vast and silent universe something like life might be quietly waiting. One of the most important places in our entire search for life. That's a heavy claim, and I don't think you can really understand why until you understand the sheer scale of what's actually down there. Because the word ocean on its own doesn't quite capture it. You need the numbers. You need to actually try to hold this size in your mind, even though, honestly, it barely fits. Let's start with something you already know. Earth's oceans, all of them combined, the Pacific, the Atlantic, the Indian, the Southern, the Arctic, every drop of seawater covering roughly 70% of our planet's surface. That's the largest body of water most of us will ever try to picture. It feels endless when you stand at the edge of it, staring out toward a horizon where water simply meets sky. Now, hold that image steady, because we're about to make it feel small. Based on the data gathered from Galileo and refined by decades of research since, scientists now estimate that Europa's hidden ocean contains somewhere between 2 and 3 times more water than all of Earth's oceans combined. Not close to, not roughly equal to, 2 to 3 times more. On a moon smaller than our own moon, wrapped in ice, hidden from every eye that ever looked up at the night sky, there may be more liquid water than exists across the entire surface of our planet. Here's the thing most people don't realize about how that's even possible. Earth's oceans are wide but relatively shallow when you consider the size of the whole planet. Even the deepest point, the Mariana Trench, only reaches about 11 kilometers down, a thin film compared to Earth's overall diameter. Europa's ocean works completely differently. Instead of being wide and shallow, it's believed to be deep, extraordinarily deep. Some estimates suggest Europa's ocean could be as much as 60 to 100 kilometers deep, wrapping entirely around the moon's rocky core like a thick, dark shell of water. Try to picture that depth for a moment, because it's almost impossible to compare to anything on Earth. If you dropped Mount Everest, the tallest mountain on our planet, into the deepest part of Europa's ocean, it would disappear completely, swallowed whole, with kilometers of water still stretching above its peak. An entire mountain, taller than anything humans have ever climbed, would vanish into that darkness without a trace. And this ocean doesn't just sit in one region, the way Earth's oceans are separated by continents and land masses. It wraps entirely around Europa's rocky interior, forming a complete, unbroken shell of liquid water beneath the ice, covering the whole moon from pole to pole. There's no shoreline, no coastline, no island rising up from beneath the surface, just one continuous, global ocean, sealed away in permanent darkness, older than almost anything we can properly compare it to. And there's another detail here, one that shifts the way you should think about the water itself. This isn't likely to be pure, fresh water, the kind you'd drink from a glass. Evidence gathered from Europa's cracked surface, particularly the reddish staining along those long lineae, suggests the ocean is salty, likely rich in dissolved minerals, similar in some ways to Earth's own seawater, though the exact chemistry remains something scientists are still working to understand. Salt water, deep, dark, mineral-rich salt water, sealed beneath 15 miles of solid ice for what may be billions of years. Now think about time for a moment, because that matters just as much as the size. Europa itself is roughly 4.5 billion years old, formed alongside the rest of our solar system. And based on current evidence, many scientists believe this ocean has existed in some form for most of that entire span. Billions of years of liquid water sitting quietly beneath the ice, completely isolated from sunlight, from the atmosphere above, from anything happening on the surface of the moon that contains it. Billions of years is a number that's almost impossible to truly picture, so let's try an analogy instead. If Europa's entire history were compressed into a single day, humans would have existed for less than the final second before midnight. Every human war, every civilization, every book ever written, every person who has ever lived, all of it would fit into that final sliver of time. And that ocean beneath the ice would have already been sitting there, undisturbed, for nearly the entire day before that. Complete isolation, complete darkness, an ocean larger than anything on our own planet, holding more water than every sea on Earth combined, sealed away for a span of time that makes human history look like a single passing breath. And yet, here's the detail that should genuinely unsettle you, gently, the way this whole story keeps doing. None of this should exist at all. Everything we know about physics tells us that something this far from the sun, this deep into the cold outer edges of our solar system, should be frozen, completely solid. Not just on the surface, all the way through. Liquid water simply shouldn't survive out here, not without some outside source of heat keeping it from freezing. And yet it has. For billions of years, this vast dark ocean has remained liquid, resisting the cold that should have claimed it long ago. So the question becomes unavoidable at this point. If Europa is this far from the sun, this deep into the freezing outer solar system, what could possibly be keeping an ocean this size from turning to solid ice? What source of warmth could reach this far and last this long, hidden beneath a moon that, from the outside, still looks pale, still, and quiet? That answer, it turns out, comes from something enormous, something violent in its own patient way, and something that has been squeezing this little moon for billions of years without ever letting go. Something enormous, something violent in its own patient way. Let's slow down and actually understand what that something is, because the answer isn't fire and it isn't sunlight, and it isn't anything you'd normally associate with warmth at all. The answer is gravity, specifically the relentless, rhythmic pull of Jupiter itself, tugging on this small moon every single second of every single day, for billions of years without pause. To understand how gravity alone could generate enough heat to keep an entire ocean liquid, you first need to picture Europa's orbit a little more precisely. It isn't a perfect circle, it's slightly elliptical, meaning Europa's distance from Jupiter changes subtly as it travels around its 3.5-day orbit, moving a little closer, then a little farther, then closer again, in an endless, repeating rhythm. That small variation in distance might sound insignificant. It isn't. Here's the thing most people don't realize about gravity at this scale. Jupiter is so massive, so overwhelmingly large, that even a small change in distance creates a real, physical difference in how strongly it pulls on Europa. When Europa moves slightly closer, Jupiter's gravity squeezes it a little more tightly. When it moves slightly farther, that grip loosens, just slightly. Squeeze, release, over and over, every 3.5 days, for as long as Europa has existed. Now imagine what that constant squeezing does to something solid. Picture holding a rubber ball in your hand, squeezing it, releasing it, squeezing it again, over and over. If you did that long enough, you'd notice something. The ball would grow slightly warm, right there where your fingers pressed into it. That warmth isn't magic, it's friction created by the material inside the ball flexing and rubbing against itself every time it changes shape. Now imagine doing that to an entire moon, not with your hand, but with the gravity of a planet 1,000 times more massive than Earth. Scientists call this process tidal heating, and it's exactly as strange as it sounds. As Jupiter's gravity flexes Europa's interior, squeezing and releasing it in that same steady rhythm, the rock and ice inside the moon actually bend. Not visibly, not in any way you could see from the surface, but internally, deep down, materials stretch and compress and rub against each other, generating heat through pure friction, the same way that rubber ball warms slightly in your palm. And this isn't a subtle effect. Estimates suggest tidal heating generates enough energy to keep Europa's core and inner layers significantly warmer than they otherwise would be, this far from the sun. Warm enough, in fact, to melt ice into liquid water and keep it that way indefinitely, despite surface temperatures hundreds of degrees below freezing, just a few dozen miles above. Gravity alone, squeezing and releasing this small moon for billions of years, has been quietly generating enough heat to sustain an ocean larger than every sea on Earth combined. But Jupiter isn't working alone in this process. Europa doesn't orbit Jupiter in isolation. The two other large Galilean moons, Io and Ganymede, play a crucial role too, through something scientists call orbital resonance. For every one orbit Ganymede completes, Europa completes exactly 2, and Io completes exactly 4. That precise repeating pattern means the gravitational pulls of these 3 moons align in predictable, rhythmic ways, constantly nudging Europa's orbit just slightly out of a perfect circle, ensuring that elliptical shape and the tidal squeezing it causes never fades away. Think about the sheer coincidence, or perhaps the sheer inevitability of that arrangement. 3 moons locked together in a gravitational dance that has likely continued, unchanged, for billions of years, each one influencing the others in a way that keeps Europa being squeezed and released endlessly. Without that resonance, without Io and Ganymede tugging at Europa in just the right rhythm, its orbit might eventually settle into a perfect circle. The tidal flexing would stop, and that hidden ocean, deprived of its only real source of warmth, would likely freeze solid within a relatively short span of geological time. And that possibility is worth sitting with for a moment, because it reveals something quietly unsettling about how fragile this whole arrangement actually is. Europa's ocean doesn't exist because the moon is naturally warm. It doesn't exist because of some ancient reservoir of heat left over from its formation. It exists because of an ongoing, active, gravitational tug-of-war between 3 moons and a giant planet. A mechanical process that has to keep happening continuously, or the entire ocean disappears. This is the detail that separates Europa's ocean from almost anything you'd naturally imagine when you picture liquid water in space. It isn't warm because it's close to a sun. It's warm because it's being physically squeezed relentlessly by forces far larger than itself. In a strange way, Europa's ocean exists not despite the crushing gravity of Jupiter, but because of it. The very thing that could have doomed this little moon to permanent solid ice is the exact same thing keeping its hidden ocean liquid. And once you understand tidal heating, another piece of the earlier mystery finally clicks into place. Remember those cracks, those long reddish lineae stretching across the surface. Remember the chaos terrain, those jumbled fields of shifted, refrozen ice blocks. All of it, the cracking, the shifting, The strange young age of the surface itself ties directly back to this same process. The same gravitational flexing that keeps the ocean liquid also stresses the ice shell above it, bending it, cracking it, forcing it to reshape itself again and again across millions of years. Everything, it turns out, connects back to this one relentless mechanism: Jupiter's gravity, aided by the precise rhythm of Io and Ganymede, squeezing Europa in an endless cycle that generates just enough heat to keep an entire ocean from freezing, while simultaneously reshaping the ice above it, over and over, for as long as this moon has existed. A moon kept alive, in a sense, by the very same force that could just as easily crush it. But warmth alone doesn't answer everything, because now that we understand how the ocean stays liquid, an even more uncomfortable question comes into focus. What is it actually like down there, in that vast, dark, endlessly squeezed sea? What conditions exist deep beneath 15 miles of ice, in a place where no light has ever reached, and where pressure builds with every passing kilometre of depth? That's where we're headed next, into the crushing, silent dark itself. Into the crushing, silent dark itself. Let's actually go there now, at least in the way our minds allow, and try to imagine what it would truly be like, descending through that ocean, beneath 15 miles of ice that no sunlight has ever managed to pierce. Because understanding the size of Europa's ocean is one thing, understanding what it would actually feel like inside it is something else entirely. Start at the very top of that ice shell, right where it meets the ocean below. By this point, you're already miles beneath the surface, further down than any submarine on Earth has ever travelled, further down than any drill has ever reached on any world humans have explored. Above you, nothing but solid ice, stretching upward for miles, blocking out every trace of the distant, dim sunlight that barely reaches Europa in the first place, and ahead of you, nothing but water, dark, silent, endless water. Here's the thing most people don't realise about light in an environment like this. It isn't just dim, it's completely, utterly absent. On Earth, even our deepest oceans retain a faint memory of sunlight for the first kilometre or so, a fading blue glow that eventually gives way to true darkness. But Europa's ocean sits beneath 15 miles of solid ice, a barrier so thick and so complete that not a single photon of sunlight has likely touched this water in millions, possibly billions, of years. This isn't nighttime darkness. This is a darkness with no memory of light at all. And it isn't only the absence of light that would strike you here. It's the absence of nearly everything you associate with an ocean back home. No waves because there's no wind to stir the surface. No surface at all in the way we understand it. Just an unbroken ceiling of ice pressing down from above. No sound of water lapping against a shore, because there is no shore anywhere in this entire global sea. Complete silence, not quiet, silence in its most absolute, uninterrupted form. Now keep descending deeper into that dark water, and something else begins to change. Pressure. On Earth, ocean pressure increases roughly 1 atmosphere for every 10 meters you descend, which is already enough to crush a submarine at extreme depths. Europa's ocean is estimated to reach depths of 60 to 100 kilometers, meaning pressure at its deepest points could reach levels many times greater than even the crushing depths of Earth's Mariana Trench. A pressure so extreme that most materials familiar to us would simply be crushed, deformed, or fractured long before reaching bottom. Try to imagine what that kind of pressure actually feels like, using something concrete. On Earth's surface, the air around you presses down with a force of about 1 atmosphere, something your body handles so effortlessly you never even notice it. Descend to the deepest part of Europa's ocean, and that pressure could climb to several thousand atmospheres, an amount of force capable of crushing solid steel structures as though they were empty soda cans. Down there, nothing simple survives, nothing unprepared. Nothing that hasn't somehow adapted to exist under that unimaginable weight of water above it. And then there's the cold, though this is where Europa's ocean holds one final quiet surprise. You might expect water this deep in the outer solar system to be freezing, barely above the melting point of ice. In some places that's likely true, but remember the tidal heating we talked about, that relentless squeezing generated by Jupiter's gravity. Near the rocky seafloor, deep beneath all that water, temperatures may actually be significantly warmer than you'd expect, potentially even warm enough to support liquid water heated directly by geological activity, similar to certain extreme environments found in Earth's own deep oceans. That contrast is worth sitting with for a moment. An ocean sealed in permanent, absolute darkness, crushed beneath pressure that would flatten steel, existing in one of the coldest regions of our entire solar system, and yet, in certain pockets, potentially warmed from below by the same geological forces keeping the whole ocean liquid in the first place. Cold above, warm below perhaps, darkness everywhere. A layered, contradictory world, existing entirely out of sight, exactly as it has for billions of years. Here's the thing that should sit with you a little longer than the rest. Gently, the way all good bedtime mysteries tend to linger. This entire ocean, this vast, crushing, lightless sea, has existed in complete isolation from the rest of the universe for almost the entirety of Europa's 4.5 billion year history. No sunlight has ever reached it. No meteorite has ever splashed into it directly. No spacecraft, no human instrument, no living eye has ever actually seen what exists at the bottom of that water, resting against Europa's rocky core. We are, in a very real sense, imagining a chamber we cannot open. A sealed world existing right here in our own solar system, close enough that spacecraft have already flown past it dozens of times, and yet completely inaccessible, protected by miles of ice and unimaginable pressure. Everything we know about it comes from indirect evidence, magnetic field readings, surface cracks, careful calculations built from decades of patient observation. Nobody has ever actually looked inside. And that absence of direct observation is exactly what makes the next question so difficult to set aside. Because an environment like this, dark, pressurized, isolated for billions of years, yet still liquid, still active, still churning with heat rising from below, sounds less like a dead, empty void, and more like something that could, potentially, support conditions for life. Not the kind of life you'd recognize instantly. Nothing swimming gracefully through clear, sunlit water. Something stranger, something adapted to exist entirely without light, entirely under crushing pressure, entirely dependent on heat rising up from Europa's rocky seafloor. And that seafloor itself, the very bottom of this hidden ocean, resting against Europa's rocky interior, deserves its own careful look. Because on Earth, our own deep, dark, lightless ocean floors are home to some of the strangest, most resilient forms of life ever discovered, thriving in conditions eerily similar to what may exist beneath Europa's ice. If something similar exists down there on the floor of an alien ocean we've never actually seen, it would be waiting exactly where we're about to look next. Waiting exactly where we're about to look next. So let's go there now, all the way down, past the crushing pressure and the absolute darkness, to the very bottom of Europa's hidden ocean, where water finally meets rock. Because this is the place where the real questions begin. Not questions about ice or gravity or heat. Questions about what might actually be happening on that seafloor in conditions no human has ever directly witnessed. To understand what Europa's seafloor might look like, we first need to look somewhere closer to home. Earth's own deep ocean, specifically the darkest, coldest, most crushed regions of our seafloor, places just as lightless and pressurized as anything waiting beneath Europa's ice. For most of human history, we assume these depths were essentially lifeless, too dark for anything to survive without sunlight, too cold, too crushed, too far removed from the energy that powers nearly every living thing on the surface above. That assumption turned out to be completely wrong. In 1977, scientists exploring the deep ocean near the Galapagos Islands, using a submersible built to withstand crushing pressure, made a discovery that reshaped our entire understanding of where life can exist. Deep on the ocean floor, in total darkness, they found cracks in the seabed, releasing scalding, mineral-rich water, heated by geological activity far below. Scientists call these features hydrothermal vents, and clustered around them, thriving in conditions that should have been completely lifeless, was an entire ecosystem nobody expected to find. Here's the thing most people don't realize about these vent ecosystems. They don't rely on sunlight at all. Every other major ecosystem on Earth's surface ultimately depends on plants and photosynthesis, converting sunlight into usable energy. But around these deep-sea vents, entirely different organisms had evolved a completely separate strategy. Certain bacteria learned to convert chemicals released from the vents themselves, minerals like sulfur and hydrogen, directly into energy, without any sunlight involved whatsoever. Scientists call this process chemosynthesis, and it changed everything about where we thought life could exist. And once that chemical energy existed, an entire food chain built itself around it. Enormous tube worms, some taller than a human being, clustered around the vents in dense colonies. Strange pale crabs scuttled across the rocks nearby. Ghostly white shrimp, blind eyeless creatures adapted entirely to a world without light, thrived in temperatures and pressures that would be instantly fatal to almost anything living on Earth's surface. An entire thriving ecosystem existing in complete darkness, entirely disconnected from sunlight, powered instead by heat and chemistry rising directly from the planet's interior. Now hold that discovery in your mind and think back to everything we've already covered about Europa. An ocean kept liquid not by sunlight, but by tidal heating generated deep within the moon's rocky core. A seafloor that may, in certain regions, be significantly warmer than the water above it, heated by that same relentless gravitational squeezing. If Earth's deep, dark, lightless vents can support entire ecosystems without a single ray of sunlight, then the conditions on Europa's seafloor may not be nearly as hostile to life as they first appear. This is exactly the comparison that transformed how scientists think about Europa. Before the discovery of Earth's hydrothermal vents, the idea of life existing beneath miles of ice in a sunless ocean would have sounded like pure fantasy. After that discovery, it became something closer to a serious scientific possibility. If chemistry and heat alone, without any sunlight whatsoever, can support entire thriving ecosystems here on Earth, there's no obvious reason the same couldn't be true in the dark, warm regions of Europa's seafloor. Of course, nobody has actually seen Europa's ocean floor. Everything here remains careful, informed speculation, built on indirect evidence and reasonable comparison rather than direct observation. But the pieces line up in a way that's difficult to dismiss. A rocky seafloor, likely still geologically active, given the tidal heating occurring throughout Europa's interior. The strong possibility of hydrothermal vents, similar to the ones discovered near the Galapagos, releasing heat and mineral-rich water directly into the ocean above. And an ocean old enough, isolated enough, that if life ever had a chance to begin down there, it's had billions of years to do exactly that. Think about what that seafloor might actually look like if you could somehow stand there yourself. Complete darkness, broken only by the faint, ghostly shimmer of mineral-laden water rising from cracks in the rock, distorting the water around it like heat rising off pavement on a summer day. Strange formations built from decades or centuries of mineral deposits, rising from the seafloor like twisted alien chimneys, and crushing pressure pressing in from every direction, a weight so immense it would instantly destroy almost anything not specifically built to withstand it. And if life truly does exist down there, drawing energy the same way Earth's vent ecosystems do, it almost certainly wouldn't look like anything familiar. No colourful fish, no graceful sunlit creatures gliding through clear water. If anything survives on Europa's seafloor, it's more likely to resemble the strange, pale, alien-looking organisms clustered around Earth's own hydrothermal vents. Simple, resilient, built for darkness, pressure, and cold rather than light, warmth, and open sky. That possibility alone is enough to make this hidden ocean feel entirely different than it did just a few chapters ago. This isn't simply a body of water sealed away and forgotten beneath the ice. It's potentially an entire undiscovered ecosystem, existing in complete isolation, following rules of survival that have nothing to do with sunlight, and everything to do with heat rising quietly from the rock below. A seafloor we've never seen, holding the possibility of something we've never truly considered finding this close to home. But heat and darkness alone don't guarantee life. For anything to actually survive down there, certain very specific chemical ingredients would need to be present as well. The same basic building blocks life depends on here on Earth. And as it turns out, evidence gathered from Europa's cracked, stained surface may already be hinting at exactly what those ingredients could be. Let's look at that evidence now, because it turns out Europa's cracked, scarred surface has been quietly offering clues about its ocean's chemistry this entire time, written in colour and mineral stains that scientists have spent decades learning to read correctly. Remember those long, reddish-brown lines crossing Europa's ice, the ones we first noticed in those early Voyager images? For years, scientists debated exactly what caused that reddish staining. It wasn't simply damaged ice, discoloured by cosmic radiation alone, though radiation does play some role in the story. The leading explanation involves something being pushed up from underneath, material carried upward through the cracks from the ocean below, then altered by exposure to Europa's harsh surface environment. Here's the thing most people don't realise about that reddish colour. Spectroscopic analysis, essentially studying how light reflects off different materials, suggests the staining likely comes from salts. Specifically, sulfate salts, similar in some ways to Epsom salt here on Earth, mixed with other compounds and altered by intense radiation bombarding Europa's surface. If that's accurate, it means the ocean beneath the ice isn't simply water. It's salty water, rich in dissolved minerals, being pushed upward through cracks and exposed along the surface for scientists to study from a distance. And salt on its own might not sound particularly exciting, but context matters enormously here. Every ocean we know of that supports life, every single one on Earth, is salty, rich in dissolved minerals that play crucial roles in biological processes. If Europa's ocean shares that same basic chemistry, salty, mineral-rich water, it starts to look less like some exotic, alien substance, and more like something startlingly familiar. A chemistry not unlike the oceans that gave rise to life on our own planet billions of years ago, but salt is only part of the picture. In 2022, scientists using the James Webb Space Telescope made a discovery that added an entirely new layer to this chemical puzzle. Carbon dioxide detected clearly on Europa's surface, concentrated specifically in a region called Terra Regio, one of those jumbled chaos terrain areas we talked about earlier. And the way that carbon dioxide was distributed told scientists something important. It didn't look like carbon dioxide delivered from outside, by comets or meteorite impacts. It looked like carbon dioxide that had come from somewhere within Europa itself. Think about what that means for a moment. Carbon is one of the most fundamental building blocks of life, as we understand it, present in every living thing on Earth, from the simplest bacteria to the most complex organisms. Finding evidence that carbon, in the form of carbon dioxide, likely originated from Europa's internal ocean rather than arriving from space, suggests the ocean contains at least one of the essential ingredients life depends on. Not proof of life, but another piece, fitting quietly into place alongside everything else. And there's more. Along with carbon dioxide, scientists have also found evidence suggesting the presence of other compounds tied to Europa's internal chemistry, hints of sulfur compounds, and indications that complex chemical reactions may be occurring where the ocean meets the rocky seafloor below. Remember those potential hydrothermal vents we discussed, similar to the ones supporting entire ecosystems in Earth's deep oceans? If similar chemical reactions are occurring on Europa's seafloor, they could be generating exactly the kind of energy and chemistry that life, in its simplest forms, might be able to use. Here's where the picture starts coming together in a way that's genuinely difficult to dismiss. A vast, ancient, salty ocean, carbon-based chemistry likely originating from within the moon itself, heat rising from a rocky seafloor, possibly through hydrothermal vents similar to the ones supporting thriving ecosystems here on Earth, and billions of years of uninterrupted time sealed away from any outside disruption for whatever chemical processes exist down there to slowly develop, react, and potentially evolve. Scientists have a simple framework for thinking about what any world needs to potentially support life, sometimes called the three ingredients. Liquid water, check. A source of energy, potentially check, through tidal heating and possible hydrothermal activity. And the right chemical building blocks, including carbon-based compounds, increasingly looking like a check as well. Three ingredients, all seemingly present, on a moon that most people have never even heard of, hidden beneath ice this entire time. And yet, here's the honest, careful truth, the kind any responsible scientist would want you to hold on to. Having the right ingredients doesn't guarantee life actually exists. Earth had these same basic ingredients for hundreds of millions of years before life first appeared, and we still don't fully understand exactly how or why that transition happened. Even here, on the one planet where we know for certain it occurred, Europa having the right chemistry proves the possibility is real. It doesn't prove the outcome, but that distinction between possibility and proof is exactly what makes this moon so quietly unsettling to think about as you drift towards sleep tonight. We're not talking about some distant, unreachable planet circling another star, too far away to ever properly investigate. We're talking about a moon in our own solar system, close enough that spacecraft have already studied its chemistry directly, close enough that missions are already underway to learn more. And every piece of evidence gathered so far keeps pointing in the same uncomfortable direction. The ingredients are there, the conditions might be right, and nobody yet knows what, if anything, has been quietly forming in that ocean for the past several billion years. That uncertainty is precisely where the next part of this story lives. Because once scientists confirmed the right chemistry might exist beneath Europa's ice, an entirely different kind of question started circulating through research communities. One people were reluctant to say too loudly, even in professional settings, not whether the ingredients for life were present, but whether something had actually used them. Whether something had actually used them. That question sits at the center of everything now, and I want to be honest with you about how scientists actually talk about it, because it isn't quite the way you might expect. This isn't a question shouted from podiums or splashed across dramatic headlines. It's quieter than that, more careful, almost hesitant, in a way that tells you just as much as the question itself. Here's the thing most people don't realize about how planetary scientists discuss the possibility of life on Europa. In public talks, in published papers, in careful, measured language, researchers rarely say the word life without immediately surrounding it with qualifiers. Potential habitability, conditions conducive to life as we know it, the possibility of biosignatures. It's a very particular kind of caution, the kind that comes from decades of learning not to overstate what evidence can actually support. And yet, underneath that careful language, you can sense something else, a quiet seriousness that wasn't always there. Think back to earlier decades when the search for life beyond Earth mostly meant searching other star systems entirely, for planets that might, someday, in some distant future, be confirmed to have conditions similar to our own. Europa changed that conversation entirely. This wasn't a planet trillions of miles away, detected only through faint wobbles in starlight. This was a moon, right here, in our own solar system, close enough to actually visit, close enough to study directly. And it had liquid water, enormous amounts of it. That single fact moved Europa from a scientific curiosity into something closer to a genuine target in the search for life. And yet, here's what makes this question so quietly unsettling, more than almost anything else in this entire story. It isn't really about whether alien creatures with faces or intelligence exist down there. Almost nobody seriously studying Europa expects that. The real question, the one that lingers in research meetings and conference hallways, is much smaller and somehow much stranger to sit with. Could simple life, microbial life, the same basic kind of organism that first appeared in Earth's own ancient oceans, exist independently, in complete isolation, beneath the ice of another world? That question matters more than it might initially seem, because of what it would mean if the answer turned out to be yes. If life arose only once, here on Earth, through some incredibly rare, nearly impossible sequence of chemical events, then life itself might be vanishingly uncommon across the universe, a cosmic accident unlikely to repeat itself anywhere else. But if life also arose independently on Europa, a completely separate world, with completely separate conditions, then life itself starts to look less like a miracle and more like something that happens naturally whenever the right ingredients and the right amount of time come together. Sit with that distinction for a moment, because it's genuinely enormous. It isn't really about Europa at all, not entirely. It's about every other ocean world, quietly drifting through our solar system and beyond. Moons like Enceladus around Saturn, icy worlds circling distant stars we've barely begun to study. If life managed to begin twice, independently, in our own solar system alone, the odds shift dramatically. Life, instead of being a rare, singular event, would start to look almost inevitable, wherever liquid water, energy, and time happen to overlap. And this is exactly the part of the conversation that scientists tend to approach so carefully, almost reluctantly, in public settings. Because confirming even simple microbial life on Europa wouldn't just be an interesting discovery about one small moon. It would fundamentally reshape how we think about our own place in the universe. It would suggest that we are not some singular, impossibly rare occurrence, drifting alone through an empty cosmos. It would suggest instead that life is something the universe does, quietly and repeatedly, wherever conditions allow. There's a particular kind of unease hidden inside that possibility, one that doesn't get discussed as openly as the excitement does. Because if life can begin that easily, that readily, in dark sunless oceans hidden beneath ice, then the universe likely contains far more life than we've ever imagined. Most of it probably simple, microbial, utterly unlike the complex, intelligent life we tend to picture when we think about other worlds. And a universe quietly filled with simple life, everywhere we haven't yet thought to look, is a strange, humbling thing to consider late at night. There's also a more immediate, more practical concern lurking behind this same question, one that occupies mission planners just as much as philosophers. If microbial life does exist beneath Europa's ice, protecting it from contamination becomes an enormous ethical and scientific priority. Every spacecraft ever sent toward Europa has been carefully sterilized, specifically to avoid accidentally introducing Earth microbes into that hidden ocean. Scientists are being extraordinarily cautious, not because their certain life exists down there, but because the possibility alone demands that level of care. And that caution tells you something important about how seriously this question is actually being taken, even without a definitive answer. Nobody builds multi-billion-dollar sterilization protocols for a possibility they consider purely theoretical. The fact that space agencies treat Europa's ocean with this level of protective seriousness reveals just how real, how genuinely plausible the possibility of life down there has become within the scientific community, even if very few researchers will say so directly and without qualification. So here we are at the heart of the mystery this entire story has been building toward. An ocean, vast and ancient, hidden beneath miles of ice, the right chemistry, quietly confirmed through careful analysis. A source of energy rising steadily from a rocky seafloor we've never actually seen. And a question sitting quietly beneath all of it, one that scientists approach with careful language and enormous caution, precisely because of how much would change if the answer ever turned out to be yes. And as it turns out, we may not even need to drill through that ice to start finding pieces of that answer. Because Europa, it seems, has occasionally been sending small clues up through the surface, all on its own. Sending small clues up through the surface, all on its own. That idea might sound almost too convenient to be true, the kind of thing you'd expect from fiction rather than fact. But the evidence for it is real, gathered carefully over more than a decade, and it centers on something happening far above Europa's frozen crust, rather than beneath it. Something rising, briefly, into open space. The year was 2012. Astronomers using the Hubble Space Telescope were observing Europa as it passed in front of Jupiter, watching carefully for any faint signs of atmosphere, when they noticed something unexpected near the Moon's south polar region. A thin trace of hydrogen and oxygen extending far above the surface in a shape and pattern that looked remarkably like water vapor, venting upward from below. It was faint, it was brief, but it was there, and it immediately reminded scientists of something already confirmed on a different icy moon entirely. Here's the thing most people don't realize about Europa's neighbor in this story, a moon called Enceladus, orbiting Saturn rather than Jupiter. Years earlier, the Cassini spacecraft had directly observed massive plumes of water vapor and ice particles erupting from Enceladus's south pole, jets powerful enough to be photographed clearly, spraying material hundreds of kilometers into space. If Europa was doing something similar, even on a smaller, less dramatic scale, it would mean this moon's ocean occasionally finds a way to reach the surface, briefly bypassing that entire 15-mile wall of ice. Think about what that would actually mean if confirmed. An ocean sealed away for billions of years, hidden beneath crushing ice and total darkness, suddenly offering a way to study its contents without ever having to drill through anything at all. If plumes of water vapor really were escaping from cracks in Europa's surface, carrying material directly from that hidden ocean into open space, then spacecraft flying through those plumes could potentially sample the ocean's actual chemistry directly, simply by flying through the right place at the right moment. That 2012 observation wasn't a one-time fluke either. Over the following years, astronomers continued monitoring Europa closely, and additional potential plume activity was detected in 2014 and again in 2016, using both Hubble and other observation methods. Each detection remained frustratingly faint, right at the edge of what current instruments could reliably confirm. Scientists' description of these events tends to use careful measured language, phrases like probable plume activity or transient water vapor signatures, rather than definitive, confirmed statements. And that careful hesitation matters because it tells you something honest about how difficult this kind of observation actually is. Europa sits roughly 628 million kilometers from Earth at its closest approach, an almost unimaginable distance for trying to detect something as faint and fleeting as a brief burst of water vapor, rising perhaps 100 kilometers above an icy surface, then dispersing again within hours. Detecting these plumes at all, even inconclusively, required pushing our best telescopes to their absolute limits. But where exactly might these plumes be coming from, if they are indeed real? This is where those chaos terrain regions we discussed earlier come back into the story, and specifically one particular area called Mannanen Crater, along with certain sections of the jumbled, fractured terrain near Europa's south pole. Some of the strongest potential plume signals appear to originate near locations where the ice shell is thought to be thinnest and most heavily cracked, exactly where you'd expect an escape route from the ocean below to form most easily. Imagine standing on Europa's surface near one of these fracture zones during one of these brief eruptions, if such a thing were survivable at all. A sudden burst of vapor and ice crystals rising silently from a crack in the frozen ground, climbing dozens of kilometers into the black sky above, catching whatever faint sunlight reaches this distant moon, before slowly settling back down or drifting off into space entirely. No sound, of course, in the near vacuum above Europa's surface, just a quiet, ghostly plume rising and falling, carrying with it whatever secrets exist in the ocean far below. And here's the detail that turns this observation from merely interesting into something genuinely significant for everything we've already discussed. If these plumes really do originate from Europa's subsurface ocean, they would be carrying, potentially, exactly the kind of chemical evidence scientists have been trying to detect indirectly this entire time. Salts, organic compounds, perhaps even direct evidence of whatever biological or chemical processes might be occurring near that hidden seafloor, lifted briefly into space, where a passing spacecraft equipped with the right instruments could actually sample it directly. That possibility completely reshapes the practical challenge facing future exploration of Europa. For decades, the primary obstacle to studying this ocean seemed insurmountable. Drilling through 15 miles of solid ice in one of the most radiation-soaked environments in the solar system remains far beyond our current technological capability and will likely remain so for a very long time. But if the ocean is occasionally venting material directly into space, drilling might not be necessary at all. A spacecraft simply needs to be in the right place, at the right moment, flying directly through one of these plumes to gather a genuine sample of Europa's hidden ocean without ever touching the surface. Of course, everything here still carries that same careful uncertainty we've encountered throughout this story. The plumes remain unconfirmed in any absolutely definitive sense, detected faintly, inconsistently, right at the edge of what our instruments can reliably measure. But the possibility alone has fundamentally changed how space agencies have designed their approach to exploring this moon. Because if there's even a reasonable chance that Europa is quietly venting samples of its hidden ocean into open space, any serious mission heading toward this moon needs to be built specifically to look for it and to catch it if the opportunity ever arises. And as it happens, that exact kind of mission was already being designed, refined, and finally launched, built specifically with these possibilities in mind. A spacecraft equipped not just to photograph Europa's cracked, fascinating surface, but to actually search for signs of the ocean hiding beneath it, plumes included. That mission represents humanity's most direct, most carefully prepared attempt yet to finally understand what's really happening beneath the ice of this small, quietly extraordinary moon. Humanity's most direct, most carefully prepared attempt yet. Before we get to that mission itself, there's one more piece of evidence worth understanding first, gathered not by a spacecraft flying past Europa, but by a telescope stationed roughly 1.5 million kilometers from Earth, staring outward with a level of precision no instrument had ever achieved before, the James Webb Space Telescope, and what it managed to reveal about this small icy moon. Webb wasn't built specifically to study Europa. Its primary mission involves peering deep into the early universe, observing galaxies so distant that their light has travelled billions of years just to reach us. But its instruments are also extraordinarily sensitive to chemical signatures, capable of identifying the precise composition of surfaces and atmospheres with a level of detail previous telescopes simply couldn't match. And in 2022, scientists turned that extraordinary sensitivity toward Europa, hoping to settle a question that had lingered since those very first Voyager images decades earlier. Here's the thing most people don't realize about that carbon dioxide detection we touched on earlier. Confirming its presence was one thing. Confirming where it actually came from was an entirely different, far more difficult challenge. Carbon dioxide arrives in the outer solar system constantly, delivered by comets embedded in interplanetary dust, scattered across icy surfaces throughout the Jupiter system. Finding carbon dioxide on Europa by itself proved almost nothing. The real question was whether this particular carbon dioxide had originated from somewhere else in space, or from somewhere deep inside the Moon. Using Webb's near-infrared spectrograph, an instrument capable of analysing light reflected off Europa's surface with remarkable precision, researchers discovered something that settled the question rather convincingly. The carbon dioxide wasn't spread evenly across Europa's surface, the way you'd expect if it arrived randomly from outer space. Instead, it was heavily concentrated in one specific location, that chaos terrain region called Tara Regio, an area already suspected of sitting above warmer, more active portions of the ice shell. That concentration told scientists something important. Material delivered from space tends to distribute itself relatively evenly, scattered across a surface over millions of years of steady accumulation. Material rising up from inside a moon, through cracks and geologically active regions, tends to cluster exactly where those cracks and active regions exist. The carbon dioxide's tight concentration around Tara Regio strongly suggested an internal origin. Carbon, quite possibly, rising directly from Europa's hidden ocean, carried upward through the same fractured ice we've discussed throughout this story. And Webb found something else in that same region, something that added even more weight to the discovery. Alongside the carbon dioxide, researchers detected evidence suggesting the carbon had been chemically processed, altered in ways consistent with having interacted with liquid water before reaching the surface. In other words, this wasn't simply carbon dioxide ice sitting passively on top of the crust. It looked like carbon dioxide that had been dissolved in the ocean, transported upward, and left behind on the surface only after the ice around it had partially refrozen. Think about what that really means. Carbon, one of the essential building blocks of every living thing on Earth, appears to be actively cycling between Europa's rocky interior, its hidden ocean, and its icy surface. Not a fossil, trapped in ice since the Moon's formation billions of years ago. An active, ongoing process, still happening, still connecting the deep, dark ocean to the frozen crust above it, right now, as you listen to this. The Moon isn't simply hiding an ancient, sealed ocean. It's an ocean still exchanging material with the world around it. Webb's observations didn't stop there either. Scientists also used the telescope to search carefully for any sign of active plume activity, hoping to catch Europa venting material into space, the same way Hubble had detected hints of years earlier. This particular search came back inconclusive. No definitive plumes were detected during Webb's observation window, though scientists were quick to note that plume activity, if it exists at all, appears to be infrequent and unpredictable, making it entirely possible for even a powerful telescope to simply miss an eruption that isn't actively occurring at the moment of observation. That inconclusive result matters for an important reason. It reminds us how much of this story still exists in that careful space between strong evidence and absolute certainty. Webb confirmed about as clearly as remote observation allows, that carbon is actively cycling between Europa's ocean and its surface. It did not confirm active plumes during its specific observation window. Science, especially science this far from home, rarely delivers everything at once. It arrives in careful, incremental pieces, each one narrowing the mystery just slightly further. But incremental as it was, this particular piece mattered enormously to everyone planning humanity's next steps toward this moon. Confirming that carbon actively cycles between Europa's ocean and surface gave mission planners something concrete and specific to search for. It meant future spacecraft wouldn't simply be guessing at what chemistry might exist beneath the ice. They would have an actual, confirmed target, carbon-rich material, likely still being transported upward from the ocean, concentrated in specific, identifiable regions like Terra Regio, ready to be studied directly by an orbiter equipped with the right instruments. And that's precisely what makes Webb's contribution to this story so significant, even without a definitive answer about life itself. It transformed decades of careful speculation into something closer to a working map. A location, Terra Regio, singled out as one of the most promising places to study Europa's internal chemistry directly. A confirmed process, ongoing material exchange between ocean and surface that future missions could specifically target. Webb didn't answer whether anything lives beneath Europa's ice, but it told the next mission exactly where to start looking, and that in this long, patient search may prove just as valuable as an answer itself. That in this long, patient search may prove just as valuable as an answer itself. And with a target finally identified, humanity's next step stopped being theoretical. It became an actual spacecraft, built, tested, and launched, carrying instruments designed specifically to study everything we've discussed so far, up close and in far greater detail than any telescope on Earth ever could. The mission is called Europa Clipper, and it represents the largest spacecraft NASA has ever built for the exploration of another planet's moon. Launched in October of 2024, it began a journey of roughly 5.5 years, traveling nearly 3 billion kilometers through the solar system, using carefully timed gravity assists from Mars and Earth to build up enough speed to reach Jupiter without requiring an impossibly large amount of fuel. A patient, calculated journey for a patient, calculated mission. Here's the thing most people don't realize about why Europa Clipper doesn't simply orbit Europa directly, the way you might expect. Jupiter's magnetosphere bathes this entire region of space in extreme radiation, intense enough to seriously damage sensitive electronics over time. Orbiting Europa continuously would expose the spacecraft to a lethal dose of radiation within just a few weeks, far too short a window to gather meaningful long-term data. So mission engineers designed something more clever instead. Europa Clipper will orbit Jupiter itself, making dozens of close flybys past Europa, each one lasting just long enough to gather data before retreating to safer distance, allowing the spacecraft's electronics time to recover between each pass. Across its planned mission, Europa Clipper will perform at least 49 close flybys of Europa, some passing as near as 25 kilometers above the surface. Each flyby offers a brief precious window, gathering data before Jupiter's radiation forces the spacecraft to retreat once again. It's an unusual way to explore a world, approaching again and again in careful, measured passes, rather than settling into a single steady orbit. But given the environment surrounding Europa, it may be the only realistic way to study this moon safely at all. And the instruments this spacecraft carries were chosen specifically to answer the questions this entire story has been building toward. A high-resolution camera system designed to map nearly the entire surface of Europa in far greater detail than ever before, potentially finally confirming, once and for all, whether those elusive plumes are real. An ice-penetrating radar instrument capable of sensing structures beneath the surface, potentially measuring the actual thickness of the ice shell, and searching for pockets of liquid water closer to the surface than the main ocean itself. There's also a magnetometer on board, an updated, far more sensitive descendant of the very instrument that first detected Europa's ocean back in the 1990s aboard the Galileo spacecraft. This new instrument will measure Europa's magnetic field with much greater precision, refining our understanding of the ocean's depth, its salinity, and potentially even revealing new details about its overall structure that Galileo's original instruments simply couldn't detect. And critically, Clipper also carries a mass spectrometer, an instrument specifically built to analyze the chemical composition of any material it encounters, including, if the mission gets fortunate timing, material from an actual plume sampled directly as the spacecraft passes through it. Think about what that would actually mean if it happens. After decades of indirect evidence, magnetic field readings, surface staining, faint telescope observations, a spacecraft could finally fly directly through material erupting from Europa's hidden ocean, analyzing its chemistry molecule by molecule without ever needing to drill through a single mile of ice. It would be the closest humanity has ever come to directly sampling an alien ocean, and it would happen not through some dramatic landing or drilling operation, but simply by flying through the right patch of empty space at exactly the right moment. Europa Clipper is expected to arrive at Jupiter in April of 2030, beginning its primary science mission shortly afterward. That means, as you're listening to this right now, this spacecraft is somewhere out there, still traveling, still years away from its destination, carrying instruments built specifically to answer questions people have been quietly asking about this moon since Galileo first noticed it, glinting faintly beside Jupiter more than 4 centuries ago. Here's an important detail worth understanding clearly, though, because it shapes exactly what this mission can and cannot tell us. Europa Clipper is not designed to detect life directly. It carries no instruments capable of definitively confirming or denying the presence of living organisms beneath the ice. Its actual goal is more foundational than that, and in some ways, more important. Its mission is to determine habitability, to measure as precisely as possible whether the conditions beneath Europa's ice could support life, without necessarily proving whether anything is actually living down there. That distinction matters enormously, and it's worth sitting with for a moment. Europa Clipper won't give us a final answer to the biggest question this entire story has been circling, but it will tell us, with far greater confidence than we've ever had before, exactly how likely that answer is to eventually be yes. It will measure the ice shell's thickness precisely. It will refine our understanding of the ocean's depth and chemistry. It will search directly and carefully for plumes, and if it finds one, it will fly straight through it, gathering data no telescope on Earth could ever hope to capture. And in a very real sense, that makes Europa Clipper humanity's closest look, yet at a mystery that has been slowly unfolding since the very first grainy Voyager images revealed cracked, unusually smooth ice back in 1979. Every chapter of this story, the ocean's discovery, its staggering scale, the tidal heating that keeps it liquid, the chemistry hinting at the right ingredients for life, all of it has been building toward this single, patient spacecraft, quietly crossing billions of kilometers of empty space, carrying with it humanity's most careful, most determined attempt to finally understand what's really happening beneath that ice. Humanity's most careful, most determined attempt to finally understand what's really happening beneath that ice. But it's worth pausing here before going any further to understand exactly why this mission had to be designed so carefully in the first place. Why no spacecraft simply settles into a comfortable, steady orbit around Europa itself. The answer involves an invisible danger, one that has quietly protected this moon's secrets for billions of years, long before any spacecraft ever attempted to get close. Jupiter isn't just enormous, it's magnetic in a way that's difficult to properly compare to anything else in our solar system. Its magnetic field is roughly 20,000 times stronger than Earth's, generated deep within its interior by swirling currents of liquid metallic hydrogen, a material that exists nowhere else in our solar system in such quantity. That magnetic field extends far beyond Jupiter itself, stretching outward for millions of kilometers, capturing charged particles from the Sun and whipping them around at tremendous speeds, forming an enormous, invisible region of radiation surrounding the entire planet. Here's the thing most people don't realize about how dangerous that radiation actually is. Europa sits directly within this hostile region, close enough to Jupiter that radiation levels near its orbit are considered among the harshest anywhere in our solar system, far more intense than anything astronauts experience even during long missions aboard the International Space Station. A human standing unprotected on Europa's surface would receive a lethal dose of radiation in a matter of hours, not from any single dramatic event, but simply from the constant, invisible bombardment of high-energy particles trapped within Jupiter's magnetic field. Think about what that radiation actually does at a physical level. High-energy particles, moving at close to the speed of light, constantly slam into anything orbiting near Jupiter, tearing through unprotected electronics, degrading solar panels, and breaking down materials that would otherwise last for decades in calmer regions of space. This is precisely why Europa Clipper's engineers built an unusual, thick-walled vault into the heart of the spacecraft, a heavily shielded compartment specifically designed to protect its most sensitive electronics from this relentless bombardment, allowing the mission to survive dozens of close flybys rather than being destroyed within its first few weeks. And here's where this detail connects back to everything we've discussed about Europa's hidden ocean, in a way that's genuinely worth sitting with. This same harsh radiation, the very thing making exploration so difficult and dangerous, also plays a direct role in shaping the chemistry we've been discussing throughout this entire story. Remember those reddish stains along Europa's cracked surface, the ones hinting at salts pushed up from the ocean below? Scientists believe intense radiation actually alters those surface materials once they're exposed, breaking apart simple molecules and reforming them into new compounds entirely, some of which might be relevant to the ingredients needed for life. In other words, the radiation isn't simply a hazard to overcome. It's an active participant in Europa's chemistry, constantly reworking whatever material rises up from the ocean and gets exposed on the icy surface above. This creates a strange, almost contradictory relationship between danger and discovery. The same environment that makes this moon so difficult, so dangerous for us to explore directly, may also be helping create some of the very chemical clues scientists rely on to study what's hidden beneath the ice in the first place. But there's a deeper, more unsettling way to think about this radiation too, one that connects directly back to the question of life we've been circling this entire story. If simple organisms do exist somewhere within Europa's ocean, they would need to be sealed away, protected from this surface radiation, by that same 15-mile shell of ice we discussed earlier. Anything living near the surface, in the outermost layers of ice, would be destroyed almost instantly by radiation this intense. Life, if it exists at all, would need to remain buried deep, far beneath the ice, near that warm, dark seafloor, permanently shielded from the hostile environment above. And that requirement adds a strange kind of protective irony to this entire mystery. The radiation surrounding Europa is fierce enough to sterilize its surface completely, destroying any organic material almost as quickly as it arrives from the ocean below. And yet, that same radiation may be exactly what has kept Europa's ocean so pristine, so isolated, so completely sealed away from outside contamination for billions of years. a harsh, hostile shield, guarding this hidden world from the very same forces that make it so difficult for us to ever properly investigate. This is also precisely why Europa Clipper's mission design matters so much, and why its flyby approach, rather than a standard orbit, represents such a carefully considered solution. Each close pass near Europa exposes the spacecraft to intense, potentially damaging radiation for a relatively brief window, before retreating to calmer regions around Jupiter, allowing its systems time to recover before the next approach. It's a slow, patient, deliberately cautious strategy, built specifically around respecting just how dangerous this environment actually is. And there's something quietly poetic about that approach, if you sit with it for a moment. Humanity's most advanced attempt yet to understand this hidden ocean requires moving carefully, cautiously, approaching again and again in brief, measured glimpses, rather than settling in for one continuous, uninterrupted view. In some ways, that mirrors the entire story we've been telling. Small pieces of evidence gathered slowly across decades, one careful glimpse at a time, rather than one single dramatic revelation. Radiation that both threatens and shapes, danger that both hides and helps preserve, a moon that guards its ocean fiercely, even as it occasionally, quietly, offers up small clues to anyone patient enough to keep watching. And if that ocean truly has remained this sealed, this protected for billions of years, then whatever exists down there, whether it's simply water and rock or something more, has had an extraordinarily long, undisturbed span of time to exist exactly as it is. Which brings us, finally, to the question this entire story has been quietly building toward from the very beginning: what it would actually mean for us, for how we understand our place in this vast and silent universe, if something truly is living down there, waiting in the dark. What it would actually mean for us, if something truly is living down there, waiting in the dark. Let's sit with that question now, fully, without rushing past it, because it deserves more than a passing thought before you drift off tonight. Not the excitement of discovery alone, but the quieter, deeper implications, the ones that reach past Europa entirely and settle somewhere closer to home. Start with the simplest version of this thought experiment. Imagine for a moment that Europa Clipper, or some future mission after it, finally confirms it. Not intelligent life, not creatures with thoughts or faces or any kind of awareness we'd recognize. Just simple, microbial life, similar to the earliest organisms that appeared in Earth's own ancient oceans, discovered thriving somewhere near Europa's dark, warm seafloor. A single confirmed detection. One small, undeniable sign that something, however basic, is alive down there. Here's the thing most people don't realize about why that discovery, even in its simplest possible form, would matter so profoundly. It wouldn't just answer a question about one small moon, it would answer, or at least begin answering, one of the oldest questions humanity has ever asked itself, staring up at the night sky. Are we alone? Not alone in the sense of nearby neighbours or friendly signals from distant stars, but alone in the much deeper sense, the question of whether life itself is something rare, precious, and nearly impossible, or something the universe produces readily, wherever the right conditions happen to align. Think back to what we discussed earlier, about life potentially arising independently, twice, within our own solar system alone. If that happened here, in our own cosmic backyard, on a moon this small, this cold, this seemingly inhospitable, then the odds shift dramatically for everywhere else. Every other ocean world, every icy moon circling distant planets we've barely begun to study, every rocky world orbiting some star far beyond our own, suddenly becomes a slightly more plausible candidate for harbouring life of its own. The universe, instead of feeling emptier, would suddenly feel unimaginably fuller. And there's a strange quiet comfort hidden inside that possibility, even as it also carries a genuine sense of vertigo. Comfort, because it would mean we are not some impossible, singular accident, adrift entirely alone in an indifferent cosmos. Vertigo, because it would mean the universe is far stranger, far more populated, and far less centered around us than we've ever fully allowed ourselves to imagine. Both feelings existing together in that same quiet moment of realization. Here's another angle worth sitting with, one that scientists themselves quietly grapple with. If life exists on Europa, entirely independent from life on Earth, it likely evolved along a completely separate biochemical path, shaped by entirely different conditions, entirely different chemistry, entirely different pressures and constraints. It might not resemble Earth life at all, not even at the most basic microscopic level. Studying it, even just simple microbial organisms, could reveal something we've never had access to before. A second example of life, an alternative version of what biology is even capable of becoming, when given billions of years and a completely different starting point. And yet, alongside all of that wonder, there's a quieter, more unsettling thread running underneath. One that circles back to something we touched on earlier in this story: complete isolation. Whatever might exist beneath Europa's ice has spent billions of years sealed away, entirely cut off from sunlight, from the rest of the solar system, from any contact with anything beyond its own dark, crushing ocean. If something truly is alive down there, it has existed this entire time in a form of solitude almost impossible for us to properly imagine. Utterly alone, in the deepest, most literal sense of that word, for the entire span of its existence. That thought, more than almost anything else in this story, is worth letting settle quietly in your mind as you drift towards sleep. An entire ecosystem, however simple, however microscopic, existing in total isolation, in permanent darkness, completely unaware that anything else exists anywhere in the universe at all. No sky to look up at, no stars to wonder about, no way of even sensing that a moon, a planet, a sun, or countless other worlds exist anywhere beyond its own small, sealed, lightless home. If it exists, it has never known anything else. And perhaps that's exactly why this particular mystery feels so quietly personal, even though it concerns a moon hundreds of millions of kilometers away. Because in some strange, distant way, it mirrors something about our own condition too. We also exist sealed within our own particular boundary, the thin edge of our atmosphere, the limits of our own perception, wondering endlessly what else might exist beyond what we can currently reach or observe. Europa's ocean, isolated beneath its ice, and Earth, isolated within the vastness of space, aren't really so different when you consider the scale of everything surrounding both of them. We don't yet know the answer to this question. Europa Clipper won't necessarily provide it, not with total certainty, not on its own. It may take additional missions, additional decades, additional careful, patient searching before humanity finally learns whether that hidden ocean holds anything alive within it. But the question itself, now that it's been asked so seriously, so carefully, by so many dedicated scientists, isn't going away. It sits there now, quietly, alongside everything else we've learned about this moon, waiting patiently for its answer. And maybe that patience is the most fitting way to end this particular chapter of the story. Because Europa itself has waited an extraordinarily long time already, sealed beneath its ice, holding whatever secrets it holds, for billions of years before any human even noticed it existed at all. A little more patience, a little more careful searching, seems like a small thing to ask compared to everything the ocean has already endured, quietly in the dark, this entire time. Quietly in the dark, this entire time. Let's stay with that image for a little while longer, because I think it's the right note to close on tonight. A small pale moon drifting silently beside a giant planet, holding an ocean larger than every sea on Earth combined, sealed away for billions of years beneath ice thick enough to bury hundreds of skyscrapers stacked one on top of another. Patient, silent, utterly indifferent to whether anyone was ever watching. Think about everything that had to happen for us to even know this ocean exists at all. A scientist, centuries ago, pointing a simple handmade telescope toward Jupiter, noticing 4 tiny points of light where none should have been. Decades of careful observation afterward, grainy photographs slowly sharpening into clearer and clearer images. A single instrument aboard a spacecraft in the 1990s, sensitive enough to detect a magnetic whisper, revealing liquid water hidden beneath solid ice. And now, a spacecraft the size of a basketball court, quietly crossing billions of kilometers of empty space, carrying humanity's most careful attempt yet to finally understand what's really down there. Here's the thing most people don't realize about a moon like Europa. Once you've spent this much time thinking about it, it doesn't care whether we ever find it or understand it or send spacecraft to study it at all. It has existed exactly as it is, sealed and silent and vast, for 4.5 billion years, completely indifferent to whether anything beyond its own icy shell ever noticed. And yet, here we are anyway, reaching across hundreds of millions of kilometers, simply because we couldn't stop wondering what might be hiding beneath that ice. That persistence, that refusal to simply look away from a mystery, this distant and this difficult, says something quietly important about who we are. We are, as a species, creatures who look up at a sky full of countless points of light. And instead of feeling small and turning away, we build telescopes and spacecraft and entire careers dedicated to understanding what those distant lights might actually be. We are the part of the universe that noticed itself and then decided to keep looking closer, no matter how difficult, no matter how far away the answers might be hiding. We are the universe noticing itself. Sit with that phrase for a moment, because I think it captures something true about this entire story and about so many others like it. Every atom in your body, every atom that makes up Europa's ice, its hidden ocean, the rocky seafloor at its deepest point, all of it originated from the same cosmic history, forged in ancient stars, scattered across space, eventually gathering into planets and moons, and eventually into curious, wondering creatures capable of asking these questions in the first place. And in that sense, when we study Europa, when we send spacecraft to measure its ice, its ocean, its chemistry, we aren't simply investigating some distant, unrelated object. We're the universe turning its attention toward another small piece of itself, curious about what conditions elsewhere might have produced, curious about whether the same story that unfolded here on Earth might have quietly repeated itself in the dark, on a moon most people will never even hear the name of. We still don't know the answer. Europa Clipper hasn't yet arrived. The ocean remains sealed, exactly as it has been for billions of years, keeping its deepest secrets exactly where they've always been. But something has changed, quietly, over the course of this story we've told tonight. Europa isn't simply a distant, forgotten moon anymore, not to you, not after everything we've walked through together. It's become something closer to a held breath, a question, patiently waiting for its answer, somewhere out there in the dark, close enough that we might actually live to see it answered. And maybe that's the most fitting way to think about it, as you finally let yourself drift off tonight. Somewhere out there, hundreds of millions of kilometers away, a small moon continues its quiet orbit, exactly as it has for billions of years, squeezed gently by the gravity of the giant planet beside it. Its hidden ocean, staying liquid, its ice slowly cracking and healing over and over in that same patient rhythm it has followed since long before anything on Earth ever thought to look up and wonder. The next time you find yourself outside on a clear night, look up toward Jupiter if you can find it. You won't be able to see Europa itself, not with your own eyes. It's simply too small, too distant, too faint against that brilliant, banded planet beside it. But it will be there anyway, exactly where it's always been, holding its ocean, keeping its secrets, waiting quietly for the next spacecraft, the next careful measurement, the next small piece of evidence that finally brings us closer to understanding what's hiding beneath its ice. Thank you for spending this time with me tonight, drifting through the story of this strange hidden ocean, sealed away in the cold and the dark, so much closer than we ever imagined. If you enjoyed this quiet journey through the ice and mystery of Europa, consider leaving a like or subscribing for more nights like this one. It's a small gesture, but it helps this channel keep reaching curious minds like yours, drifting off to sleep with the same quiet wonder we've shared tonight. Sleep well tonight, knowing that somewhere out there, in the cold and the dark, a hidden ocean continues its ancient, patient rhythm, exactly as it has for billions of years. And the next time you look up at the night sky, remember that some of its deepest mysteries aren't hiding in some distant galaxy, impossibly far from reach. Some of them are much closer than that, quietly waiting right in our own cosmic backyard. Good night, and keep looking up at the stars.